Good afternoon, everybody. We're going to go ahead and get started with our final video section of this unit. We're going to go ahead and look at what happens when we represent electrons in atoms. Now, we spent time talking about what happens when we change up the neutrons, but we now have to start looking at what happens to these electrons and how we figure out some of the information about them. So, we use two main models in order to do this. We use Bohr diagrams and we use electron dot diagrams, or Lewis structures as we'll call them. But keep in mind, these are going to be two simple ways that we can use to represent the electrons in an atom, in a neutral atom that we're going to deal with. So start with Bohr diagrams. Now, how do we remember these? We call them the Bohr ring diagrams. Why do we call them Bohr ring? Not because they're not interesting. Well, they're not really that interesting, but because they're going to deal with a certain number of rings. These diagrams are going to be used in a couple of activities that we're going to do. So just keep in mind. Now, quick review. The rings are going to represent electron shells or electron levels. The dots are going to represent the electrons themselves. Let's practice with potassium. So, draw a ring for each electron shell that the atom has. We can tell this piece of information by finding out which period it's in. So remember, groups go down this way and our periods go from left to right. So looking down on our periodic table, we see that it's in the same period or row number. It has 4 electron shells. It's in the 4th period, 4 electron rings. Now, 3, 4. All right. Now, this is going to be our base, per se. Now, the next thing that we need to do is we need to start filling in electrons. So, add the dots for the electrons. How many electrons does potassium have? Going back to our previous notes, we know that in a neutral atom, we have the same number of protons and electrons. So, according to our periodic table, atomic number 19, so that means it has 19 electrons. Now, how do we fill up these shells? You'll just randomly start putting dots everywhere and say, okay, things are okay? Or is there some sort of method to the madness? There is a method. The first and smallest shell, starting from the inside, can only hold 2 electrons, the second shell 8, third shell 8, and then it builds from there. So let's take a look at what we have here. I made my 4 rings, and I'm going to start filling from the inside. 1, 2. Now, once I put the 2 on that inside ring, I can't put any more there. I have to go to the next level. So 1, 2, 3, 4, 5, 6, 7, 8. The second ring can hold up to 8 electrons. Now, with this piece of information, how many electrons have I already taken care of? Well, 2 on the inside and 8 on the next ring tells me that I've taken care of 10. So I have 9 left to go. Let's keep filling. 1, 2, 3, 4, 5, 6, 7, 8. Now I have 18 represented, but I have 19 electrons total. So on my outer ring, I only have 1 electron to worry about here. Okay, now this will be my Bohr diagram for potassium. Not bad. Now, when we deal with the transition metals, it gets a little bit more complicated, but that's why we always save that one for much later. Now, taking the other approach, which I think most people will like because these can be very easy to deal with, we'll look at what are called the electron dot diagrams or Lewis structures. There are 2 things that we need for the electron dot diagrams. We need the atomic symbol and the number of valence electrons. Remember, the valence electrons are the ones that are on the outside ring of the atom. So let's see what information we're dealing with, because we're going to stick with potassium. Well, the symbol is K on the periodic table, so just pull that. And since it's in group 1, the alkali metals, we know that it has 1 valence electron. So let's see, 1 valence electron and the symbol is K. All I'm going to have to do is draw 1 dot to represent the 1 electron. So write the symbol, draw the dots around for the number of valence electrons. Start on one side, then we sort of just pair them up as we go. So we have potassium, K, with 1 dot. And we're finished. La. Okay, now I'm going to do the same thing for sulfur. Taking a look at the periodic table, Remember, this is why I said that we had a difference between the A groups and the B groups. This is where the A groups part comes in. What group is sulfur a part of? It's a part of group 16 or group 6A. So that being the case, the 6A is going to tell us that it has 6 valence electrons. Well, let's write our symbol first. So we got an S for sulfur, and now I need 6 dots to represent the 6 valence electrons that sulfur has. And I'm done. That really is literally all. Now, take some time, and I want you all to practice on your own. Got a card sort handout that you're actually going to work on a little bit and get a chance to draw not only the Bohr diagrams, but also Lewis dot structures and calculate protons, neutrons, and electrons and so forth to make sure that you understand what we're doing. Take your time, go through this, review so that you'll be prepared when the test comes. Have a great day, and I look forward to seeing you in class.